This is a proof that's beyond the course, the actual proof of Newton's fractional binomial, but we'll get to that at the end. So we just need to know how to apply that formula in the formula rather than proof. But we get to that. So let's start with the first question. Okay, so we had question 1. We had 2x to the 6 plus x squared over q and to the 10, and q is not 0. And the coefficient of the term in x40, x to the power 40, the coefficient of this is 12 times the coefficient of x36. So this one, that's 12 times more. This one here. Okay, find q. All right, so Tamara, did you get an answer for this one?
Yes.
Share it.
Q is 5.
Okay, we'll have a look. All right, so you can always generalize binomial using the sum of series symbol. So it's 10 terms. You start at k equal to 0. You do 10 choose k. And I'm just forming a general from here. You have 2x to the 6. And that's going to be 10 minus k then. That would be this term. And then the second term would be just to the power of k. I'm just forming just a general form. You didn't need to do this. I'm just showing that you can. Then I would suggest that we can use this. If I just expand this a little bit more, and I'm just looking at the coefficients. So the coefficient of the x40 term is equal to 12 times the coefficient of the x36 term. Okay, so let's look at the 36th term. I'm only going to look at the coefficients. So that's going to be 12 times the coefficient is going to be 10 choose 6. If it's the 30, well, actually, I'm jumping to this. Are we comfortable that it would be 10 choose 6?
Yes.
Okay, good. To get to the power 36, you have to manipulate this and make sure that you would make 36, but it would be 10 choose 6. Looking at the coefficients, it'll be, I think we get 2 to the 4, because this 2 is going to be to the 4, and because 10 minus 6, and then we have, it's going to be q to the negative 6, because it's q to the, it's below. Hopefully you followed that. It wasn't very well explained, but 10 choose 5 on this side then. Hopefully you found that, and that's going to be 2 to the 5, and then q to the minus 5, because it's going to be the 5th or 6th term in the expansion. Equating these using the calculator, I won't go through because I think you both got 5 as the answer. You will get q is equal to 5. This is more when you want to go back over it and you can't remember how to do it. Q is equal to 5. So we just, you have to figure out, it was 10 choose 6 and 10 choose 5 would have been x to the 40 and x to the 36 using the x powers. So hopefully that made sense. Perhaps I won't spend as much time on the other ones. The second question, Sean, any answer for the second one?
I got 2 sets of answers. When p is negative 5, q is negative 17, or when p is 3, q is 15.
Okay, yeah, that's correct. Tamara, are you happy with that answer?
Yeah, but can we go through this one again?
Yeah. Okay. So let's we're given something in the question, so this is question 2. 1 plus x cubed, and it's 1 plus px to the 4. We're given that that equals 1 plus qx plus 93x squared plus all the way up to p to the 4 x to the 7. Okay, so it doesn't make sense that there be a x to the 7 term given an x cubed and an x to the 4.
Yeah.
Find the possible values of p and q. So I presume the best way of doing this is just to actually expand these two terms. So I'm going to expand this one I'll use Pascal's triangle this time. So the first is just going to be 1 to the power of 3 plus then 3, 3, 1, isn't it? So it's going to be 3x plus 3x squared plus x cubed. You okay with that, Tamara?
Yeah.
So I've expanded that. I'm going to now expand this to the power of 4. So that's going to be 1, 4, 6, 4, 1 using Pascal. So it's going to be, okay, so yeah, we've no other coefficients other than p and 1, which is cool. So we get 1 plus 4p to the x, 6, then p squared x squared, isn't it? And then it's going to go up like that. It's going to be 4p cubed x cubed. Of course, they're going to have the same power, plus p to the 4 x to the 4. Okay, so hopefully that made sense. Stop me if I'm not making sense tomorrow. Sean, what did you do from here?
I found the ones that would make up the x coefficient and the ones that make up the x squared coefficient.
Okay, so you just did so you know that, qx is here, and where are we going to get the x coefficients from here? So qx is going to be equal to, well, let's look at the x coefficients. We're going to get this 4px when it's multiplied by 1 is going to be a x coefficient, I think. And this 3x when multiplied by that 1 is going to be another x coefficient. I think. Have I missed? No, yeah. I think that's it. So therefore, the x's don't really matter anymore because they all have an x term. So we know we have one equation now with the p and q. And we're going to do something similar to find out the... Oh, there's an x squared coefficient here of p, isn't there? And that's going to... Yeah, okay. So let's find the x squared coefficient as well. Oh, that's not as easy, is it? Oh, it's up here, 93x squared, and let's find out the all x squareds. So it's going to be 6px squared when it's multiplied by 1. P squared x squared. We're going to have when this multiplies by this is going to give me a 12px squared, and we should... when this multiplies by 1 is going to be another x squared. Now I'm just doing this now. I think is that all the x squareds?
Yep, all of them.
I think we have them all. Yeah, because 1 times that. Okay. Yep. And then we do the same thing. So 93 equals 6p squared plus 12p, then removing all the x squareds, plus 3. Okay, so we have two equations, two unknowns. Not particularly nice, but let's solve this one. I think we can just solve this one. It's a quadratic. There's no q's here, so that's pretty good. So if I subtract the 90, I get 6p squared plus 12p minus 90. This looks like it's going to factorize, just divide by 6, I suppose. P squared plus 2p minus 15 equals 0. Okay, this is going to factorize quite nicely. P and 5 and 3 plus 5 minus 3. Okay, so that means we have two answers. So this is where you got your two answers, Sean. P can either be minus 5 or 3. Substitute them back into this equation, and we get values for Q. What did you get for Q, Sean?
Negative 17 and 15.
Okay, so when you subbed it in minus 5, you got negative 17, I'm presuming. And we get you sub in 3, you get 15. Okay, so okay, yeah. Tamara, you happy with that?
Yeah.
Okay. All right, let's move along to question 3. Any issues with question 3?
I don't think so, assuming that I got it right.
That is very true. Let's get your answer. So, Sean?
2025.
Mara? You there?
Yeah, sorry, I was still writing from the one before.
Okay. You get answer.
I got through like a bit of it, but I didn't get to the end.
Okay. I'm just going to listen to you now, Sean. You're going to take us through it.
Okay.
Okay. I'll write the question. And then,
Okay.
So it's this 3x squared plus 5x minus 2. Write down the quadratic in the form ax minus b times x plus c. So a bit of factorizing. So I presume you're able to do that. So let's get your answer to part A. What was it?
3x minus 1, x plus 2.
Okay, yep, that makes sense. All right, so in part B, then as hence or otherwise, find the coefficient of the x to the 9 term. Okay.
So then
okay.
I broke it up into those two and put them each to the power of 5.
Yep. 3x minus 1 to the power of 5, and 2 to the power of 5, okay.
And then from each of them, since it's going to be x to the 9, we need the x to the 5 and the x to the 4 coefficient.
That would make sense. Okay, so we need x to the 5 and x to the 4 from. Don't need anything else.
Yeah.
Because it will multiply to give x to the 9. Okay, so let's do that.
So from the first one, the x to the 5 is just going to be 3x to the 5. And then the x to the 4 is going to be 5 choose 1. So 5 times 3x all to the 4 times negative 1.
Okay, so it's going to be, so it's going to be the first two terms of this one, isn't it? Yeah.
Yeah.
So 3x to the 5, which we'll multiply out in a second. And then, yes, so 5 choose 1. And yes, that all makes sense.
Then,
to the power of 1 if you want, but we don't need that. Okay, so we have that. That's
same idea for the next one. It's just going to be x to the 5 and 10x to the 4 because it's 5 times 2 times x to the 4, yeah.
Okay, so you've jumped a little bit, but okay. Hopefully that makes sense. There are more terms in both these, but we do not need any more. So let's tidy this one up because we're going to end up multiplying, I presume.
Yep.
Sorry, I'm taking over. You do it.
So 3x to the 5 is 243x to the 5. And the other one, if you multiply out, it's going to be negative 405x to the 4.
Sorry, negative
405x to the 4.
Yep. 4, and it's still going to be multiplied by x to the 5 plus 10x to the 4. Okay. And there is more, but we will do it. Okay, so you're going to have to multiply that by that, and then that
by that. And then doing that gets you 2025, I think.
Okay, so we won't do that. 2025 x to the 9 when you combine all like terms, yeah?
Yeah.
And that's it. Okay, Tamara, you okay with that?
Yeah.
Sweet. All right, so now it's the final one, question 4, which was the one that, of course, will cause some difficulties. And I see, Sean, you put in, is that Sean or Tamara? You put in an extra question.
That was Tamara.
Okay, I'll try and get to that too. All right, so use the fractional binomial theorem to show that 1 over x, 1 minus x square root is approximately equal to 1 plus x squared over 2 when x is...
I thought you'd do this just by finding the first few terms for each of them and putting it together, but that didn't work. So maybe I did it wrong.
It is how you do it, exactly how you do it. So let's just make sure you have it done correctly. Yeah, so this is a bit like a Maclaurin series, isn't it?
Mm-hmm.
Because you're only estimating, really. It's not an exact answer, and hence why there's not a. So in fractional, it won't expand nicely, and that kind of makes sense because there's square roots here, and you're dealing with irrational and rational answers. Okay, but it's a bit like a Maclaurin series. You just have to put it together. So let's split it apart. Let's take this and split it apart into its there's two binomial expansions really here. It's 1 plus x to the half
times 1 minus x to the negative half.
Exactly. Times 1 minus x to the negative half. Yeah, because they're both square rooted, but this one, of course, is below. So, but it could be a product if you do this like that. So hopefully, so far so good. So that means I have to expand this. So let's start with this, and then I'll do this one in a second. 1 plus x to the half. Now that's going to be the sum of, and this is in your formula booklet.
Is it?
Hold on. Sure it is. Where is it? Maybe it's not. Fractional. Binomial. Well, no, just the general theorem is. Sorry, I thought the series was in. No, I take that back. Let me just double check.
Where's the general theorem?
It's in the first section. It's on page 3.
First section.
You're looking at the new formula booklet or the old formula booklet?
This is the second one that you've given us.
It should be in there. The prior learning SLH. No, topic 1. Sorry, number algebra SLHL.
Topic 1, SLHL.
SL 1.9.
What? Oh, okay. Yeah.
Okay, it's there, but it's not. It's not written in the series form. Okay. It's written a plus b to the n is equals a to the n plus n choose 1 a to the n minus 1 and so on, and b plus and so on and so forth all the way up to b to the n. Okay.
Yeah.
Which we just did in the last question anyway. Last 3 questions all follow that. To put it in what would that look like in series form, presuming a is 1? It would look like, well, we start at 0. I'm using or, not n. It's going to be, well, it's to the power of a half. So it's a half, choose whatever the or term is.
Mm-hmm.
And then it's going to be, well, for this one, it's going to be, there's no 1 term, there's no a term, so we don't need to do this. It's just b.
Yeah.
So it's just x to the power whatever or is. So when or is, like for this one, or is 0, of course. So it's just going to be the first term. After that, then it's going to be 1. So there are going to be 1s, and then so on and so forth. Because this is b to the power of 1.
Yeah.
Okay. So let's expand that. Now the tricky thing here comes with the coefficient, because it's a non-calculator question. So the coefficient using this half. Okay,
the calculator can't do it with fractions anyway, I think.
No. So the first term is going to be 1. We know that anyway, because
it's going to be 1 to the, yeah.
Does the second term really? So let's just look at the coefficients. So n choose 0 is 1. We're happy with that. We always know that. So in this one, it's going to be a half choose 0. The second one's going to be a half choose 1, which perhaps is slightly unfamiliar. How does that look like using the NCOR formula? It's going to be n factorial, the top. So this is just using the formula from the formula booklet.
Yep.
Half factorial, all over 1 factorial, and then a half minus 1
factorial.
Now that's, if we're not sure, that's fine. That formula.
Yeah.
Okay. All right, so we must simplify this down. So a half factorial is, well, we're going to expand this out just to take time. That's a half times, what's the next term? Half minus 1 times a half minus 2, and so on, so on, so on. That's a half factorial. 1 factorial is just 1 factorial. We'll put it in anyway. And then half minus 1 factorial is going to be a half minus 1, a half minus 2, and so on and so forth. Now, of course, we're going to get cancellations with all this, aren't we?
Yeah. So we just have a half.
We have just a half of a 1, which is just a half. Now, you won't always have to do it like this. You'll get, it's quite systematic, but we will just put in a half now. So the coefficient, this NC, or is a half, and x to the power of or, well, or is 1.
So it's just x.
So it's just x. We only need to go up as far as the x squared term, so we only need to do 1 more. Now, let's look at this again. Let's do it the slow way. And for the second expansion, we'll do it quicker, in the quick way. So it's a half choose 2 this time, which is going to be, I'm doing this slowly, a half factorial all over 2 factorial, and then a half minus 2 factorial from the same formula we just used.
Yep.
Now let's expand that. A half factorial is a half, take away 1, half, take away 2, yada, yada, yada. All over, well, 2 factorial is not going to, we don't need to expand that. And then we've got half minus 2 factorial, which is a half minus 2 times a half minus 3, forever. Now, not everything cancels out here. So you're seeing that cancels the next term. So it's only going to cancel from this back.
Yep.
So we're left with this, which we can simplify. A half times a half, well, that's going to be minus a half, so it's going to be minus a quarter.
Over 2, so minus an eighth.
Minus an eighth, yeah. So it comes down to minus an eighth. So let's put that in as our coefficient. So that's just some simple number manipulation. That's going to be now minus an eighth times, sorry,
X squared.
Yeah, or is the next term, so x squared.
Okay,
the next term
for the first one. That means
you did.
The next bit.
So on and so forth. We don't need to go any further because we know that we're going to end up multiplying these two together. So we definitely don't need an x cubed term.
Yeah.
All right. So that's the one. So let's do 1 minus x to the minus a half. Tamara, are you okay?
Yeah.
Same thing. I'll just set it up using, you don't need to do this. I'll just set it up just so we have in general. We're going to start at 0. A half, choose whatever or is again. But this time we've negative x to the power of or. Once again,
wait, is it not negative a half? Or choose r?
Yes, it is. Sorry. Yes, good spot. Yeah. If you don't have 1 here, make 1. What do I mean by that? If you have a 2 here, for instance,
you divide out by that to the power of whatever it is.
Yeah, divide out and use x over 2.
And then you just multiply it later. Yeah, that's what it is.
You can pop a 2 here in front of the sum because everything's going to be multiplied by 2 anyway. Rather than using this, because then it's going to be very awkward to do all those terms out. It can become, you would get it, but it would be confusing. So there's a hint if you're going over this in revision, you see a revision question and it's 3 minus x, just divide out by 3, factorize by 3, and have x over 3. And then therefore this would be x over 3. Okay, so let's do this out. The first term is going to be 1, so happy with that. The second term, well, the second term is going to be, for the same reason that the second term here was just a half. This one would be minus a half over 1 factorial, which is...
Yeah, but it's times negative x, so it's just a half.
Yeah, okay, you got there, but it's negative x to the 1. I'm just going to make sure we don't make the double negative mistake. Mm-hmm. The next term then is, well, it's going to be... Or perhaps we need to do it out, do we? If we think about it, it's going to be like this one. That's going to be minus a half. That's going to be minus a half.
Minus 1.
Minus 1. So let's just do that one using the same working out. Minus a half, minus 1, all over 2 factorial. So what's this going to be? It's minus 3 over 2 here.
Yeah.
Minus 3
so
over 2. Minus 3 over
4.
3/4 all over 2 factorial. And that's going to be 3/8, positive 3/8.
Mm-hmm. Okay, that is what I got then. Then that means I don't know how to multiply.
Yeah, so that's positive 3/8 from down here. So that's going to be plus 3/8. And of course, that's going to be negative x to the power of 2 this time. And you could go on, and you would have to then, if you needed more terms, you'd have to go on. But it's going to be, you can see the pattern here. It's going to be a half, and it's going to be a half minus 1 and a half minus 2 all over 3 factorial, because everything else would cancel out.
Yeah.
And I think that's in the book somewhere. They show that Newton proved that. You don't have to do this each time, but we only have this formula in our formula booklet, so we have just able to apply this formula. It should be okay. Let's tidy this up. 1, that's then plus x over 2, and then plus.
Oh yeah, that does work. At first, I had that, and then I couldn't see how the negative 8x squared and the 3 over 8x squared would be gotten rid of. But if you put them together, that just becomes 2 over 8, and then that's a quarter, which is, and then the other one's also a quarter. Okay, it makes sense.
All right, so you did, okay. We're not quite there yet. This is a long 8-mark question. This times this then. So let's set that up. 1 plus x over 2, so this is the first one, minus x squared over 8. And that's going to be times, and it has more, same as the last, 1 over x over 2. Am I off screen? I am. Plus 3x squared over 8, and so on. Okay, so these two need to multiply. When you do multiply all these terms, which, yeah, I presume you can do, but we'll just do it very quickly. 1 times, okay, this times everything here is going to be 1 plus x over 2 plus 3x squared over 8. X minus 2 times everything here is going to be plus x over 2 plus x over 4. X squared over 4, isn't it? And that next term is going to be cubed, so it doesn't matter. And then this times, that is going to be minus x squared over 8. And then anything else is going to have an x cubed in it. So I'll just ignore it. So this is just going to give me those first 3 terms. Adding like terms, well, 1 is here. After that, then x over 2 plus x over 2 is going to be just x, which I wanted, wasn't it? Yes, it was. And now I need an x squared over 2. So that plus, so that's going to be 2x squared over 8, common denominator, 5x squared over 8. 4x, take away 1, is going to be 4x squared over 8, which of course is x squared over 2. And so you could do more. And yeah, so this is the bit we needed to show. So it's approximately equal to this because, yeah, so we needed to show that it's approximately equal because there would be more terms, but it's only adding on a bit like Maclaurin series decimal places after that, after you go beyond x squareds. All right, so that's the fractional binomial theorem, which is just binomial theorem with just a few tweaks, and you can't use the calculator for n choose or, which means you have to use the formula. Okay, so hopefully that was all right. Let's look at the question Tamara put up.
Wait, but what does it mean when you have like a fractional number choose something? Because when you do it with whole numbers, it means how many ways you can choose like a group of stuff out of a set of n objects, right? But what does that mean when it's fractions?
Doesn't mean very much.
Oh, okay.
No, not in this case. Doesn't mean, logically, it means nothing really.
Okay.
It's only used to find these coefficients. I don't know where it's anywhere else it's used. It wouldn't be used. You wouldn't find it in a combinations, permutations question.
Okay.
You won't find it there. It only is used, and that's kind of part of Newton's proof, which is way beyond the course. But yeah, it doesn't make sense, does it? Of course, the half choose one doesn't really make sense. Perhaps you can look it up and see on YouTube and see if there's anything that can make it make sense for you, but I can't explain it beyond what it is.
Okay.
Which, of course, isn't a very HL way of things, but yeah, you're more than welcome to explore that. Maybe do a second IA.
Of course.
Yes, your favorite. Okay, so let's look at tomorrow's question, which was question 12 from some page or other. So consider the binomial expansion of 1 plus 2x to the minus 3 over 2. Write down the expansion in up to x cubed, which... Okay, so Tamara, are you there?
Yes, hello.
You're going to help me through this, so keep your mic on. You don't need to turn it off. So if I wanted to write it the same as I did the last time, sum terms to infinity then, because it'll expand forever, because it's going to be that fraction, same as the last one. Or is 0. What would I put in the something choose something here? So if we look back to the previous example, I put, when I was expanding this out, it was a half. You know the way when if it's 10 here, it's going to be 10 choose something, but it's a half. So it's going to be a half choose something. So we're going to use minus
2.
3 over 2, choose whatever order it's going to be. We're going to look at that on repeat. This has a 1 here, so that's okay. We don't need that term in our expansion, because it's just going to be 1 constantly, which is what you always want in these cases. And then we're going to have the second term, 2x, to whatever the OR power is, and it's always going to increase, starting at 0. So the first term of this expansion would be what, Tamara?
1.
Okay, that means we need to find the second term. Any ideas what we might start off with the second term? So that's when OR is 0, the answer is 1. So now OR is 1. So it's going to be minus 3 over 2, choose 1. And it's going to be 2x to the 1. Now that's the crucial question here. What is minus 3 over 2, choose 1? Any idea what you do?
The same like the one before where you do the factorial stuff?
Exactly, yeah. So you'd use that factorial. I'm not going to do it all out because you could just replace, you can do this, but you would just replace, what is it, minus 3 over 2 here with a half. And then what we end up is, it would be minus 3 over 2 take away. Well, maybe I will do it out just for 1. So it's going to be minus, so the formula, just get it up again. Make sure. So the formula is n factorial all over or factorial n minus or factorial. So perhaps that's when it's n over or. So minus 3 over 2 factorial all over 1 factorial, and then n minus r, so that's minus 3 over 2 minus 1 factorial. Okay. So what can I do here tomorrow? What would I do next?
So on the top it's the minus negative 3 over 2 minus 1, and then negative 3 over 2 minus 2, blah, 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 blah. And then at the bottom is 1 times, and then all that stuff again.
Okay, I think you're cutting in and out there, but I'll start it off. So that'd be that times minus 3 over 2 minus 1 times minus 3 over 2 minus 2, yada yada yada, all over 1 factorial is okay, and then this is going to be minus 3 over 2 minus 1 times minus 3 over 2 minus 2. So just keep taking away 1. So they're going to cancel out. So what we're left with is just minus 3 over 2 over 1 factorial, which is just minus 3 over 2. Okay. Where did that go? So we would have, it's just minus 3 over 2 then, times 2x to the 1, which is just 2x. Sean, do you know what the second term of this would be?
The second term would be minus 3 over 2 times minus 5 over 2 over 2, so 15 over 8.
So minus 3 over 2, so you're going to, this term is going to be included now, is it? So it's minus 3 over 2 times minus 1. Everything else is going to cancel out because you're going to have minus 3x over 2 here at the bottom, all over 2 factorial. So everything else is going to cancel out the same as it did here. So that is going to be, what did you say it was going to be? 15 over 8. 15 over 8. I think you're right.
Yeah.
It's going to be 5 over, oh yeah, there's the 5. Yeah, that's 5. That's minus 5 over 2. That's minus 3 over 2. Over 2 factorial is 15 over 8. So sweet. Plus 15 over 8 times 2x to the power of r, and it's going to be 2x squared. Okay, and so on and so forth. So you can, the next term then is going to be, if we just use this down here, it's going to be it's going to be 3 factorial on the bottom. It's going to be minus 3 over 2, minus 3 over 2, minus 1, and minus 3, minus 2, minus 2. That's going to be included as well. And you can work all that out. And then you would get another coefficient. Okay, we're not going to do it. It's going to take too, perhaps it's going to take too long with it. So we know that's minus 3 over 2. Okay, minus 5 over 2. And of course, the next one down is going to be minus 7 over 2. And if I do all that over 3 factorial, it's going to equal something. Okay, you can figure that out.
35 over 16, I think.
35 over 16. Thanks, John. 35 over 16. So I'll take your word for it because I don't want to do it. It's going to be minus 35 over 16 times 2x to the 3. Okay, I've gone a little bit small here. Oh, there's going to be some cancellations here, of course, with the 2 cubed. So tidy it up. That's going to do that. So we're going to get 1 minus 3x. And that one, that's going to take 15 over, that's going to be divided. So that's going to be 15 over 2 x squared. And that's going to be 35 over 2 as well. Minus 35 over 2x cubed. And that's as far as we need to go. Next one's going to be plus, but we don't want to work it out. Okay, so that is it expanded. Hopefully that's all right. So state part B. State the interval of convergence. So where's for the complete binomial expansion. So, okay. Where does the series converge? Sean?
Converges for x's. Oh wait, no. There's actually a rule for this.
Yeah, there is.
It looks like it would converge for x is less than 1.
It has to be this second thing. This second whole thing has to be less than
the 1.
Absolute value of this thing. As long as this is a 1, the absolute value of this thing, so this is a rule, the absolute value of this thing would have to be less than 1.
Okay.
Otherwise, it's going to diverge. It's going to be so that's just what you need to do. And then solve this. So if you want to get an actual value for x, what's x going to need to be?
Between -1/2 and 1/2.
Yeah, because divide by, so you could split that open into, well, if the absolute value of 2x is less than 1, therefore the 2x will be between 1 and -1, like that if you want. Then divide both sides by, divide everything by 2. Get that. So that's a rule of convergence. Perhaps, we'll look back over that from the textbook if you want, or if you want to ask me more questions on that, you can find them in the textbook and I'll go through that again. But that's a rule, yeah, because otherwise it's going to converge. Okay, and the last thing then, use the expansion to the term up to the term x cubed. So use this expansion up to x cubed to estimate 1.1 to the, okay. Now our expansion is of 1 plus 2x to the -3/2. So are we happy that this 2x part must equal 0.1?
Yes.
So in other words, I can say 2x is 0.1 because 1 plus what gives 1.1 and it has to be 0.1, which means x in our expansion is going to be half of that, so 0.05.
Yep.
Okay, so using that expansion then, the answers I have up from here, all I need to do is put in 0.05 here, here, and here.
That doesn't seem very nice to do.
Yeah, this would be a calculator question.
Okay.
They'd have to, because otherwise it's going to be an absolute nightmare. You're going to be multiplying 35 times 0.05 cubed. There's no way they could be. They can ask this, but if they ever do, it's going to be like 1.2, and then it's going to be your x is going to be, if they ever do, it's going to be your x is going to be 0.1 or 0.01 or something, because that's easier to cube and square than 0.5. Either that or the coefficients would have to be easier. They'd do a half. They would have done to the power of a half or something. Okay, so you can do that in your calculator. I don't have the answer to that. Approximately, no, I can't even approximate it. No idea. All right, so hopefully that made a bit of sense. Perhaps try another question or two from that, from the textbook, and if you can't do it, put it in the additional questions again, and I'll do it as well if you want. Okay, so today I'll put in the extra questions for what's next. After binomials, probably
Counting principles.
Yeah, I'll do that pretty soon. But we need to discuss IAs.
Yes.
Individually. So I will talk to Sean. I'll talk to you first, and then tomorrow, can you log back in here at 9:20?
Okay.
I'll talk to you then.
All right.
Okay.
Okay. Bye.
All right.
Okay, now the interrogation starts.